Okay, this is the handout that accompanies the Desmos activity we did today. And we're going to go over, these are the most important things that we needed to go over. Okay, so in this diagram, each dot represents a town or a city. Okay, and the county wants to put a waste recycling center somewhere. No city wants the waste recycling center near their house. So draw a bold point on the map to estimate where you think the best location for the waste management site should be. So when you look at it, so here are two towns, and the furthest way away from these towns is at these spots here. These are called vertex. This is called a vertex. So each place where these lines meet is called a vertex. This is called an edge. And these dots are called sites. And so we need to find, so from the vertex, if I drew a circle perfectly around around a vertex, this vertex is an equal distance between M, L, and B. These should be an equal distance away from this point here. So we want to find out the biggest circle that we could possibly get. So if you look at this, it kind of looks like the biggest gap space, because let's put all the points, I'm going to highlight them in blue just so we can see them really, really clearly. Okay, so all of these blue points are cities or towns. Okay, now you can see it looks like the biggest space for the biggest space that's open, it looks like it's right in there. Okay, so one of the things we did with compasses in class was we drew some circles, and the best technique for drawing circles is you put the sharp point on the vertex, and then you put your pencil here, and so if I wanted to draw this blue circle, I go from the vertex and put the pencil, open it wide to get to the first point, and I recommend twirling the paper. By twirling the paper, you're likely to keep the radius the same, because if you move this around too much, then the radius will change accidentally, and you don't want that to happen. You want the radius to stay the same. So leave the compass still and twirl the paper. Anyways, these pink and blue circles seem to have the biggest radiuses. Notice when I made a circle from this vertex, it made a smaller circle. Okay, and the point is to figure out where is the biggest circle, and it will be, the center will be at one of the vertexes. Now, notice this blue circle. There are no dots, no site dots at the center of any of these circles. Same thing with the pink one. There's no site dots in the center of these. I saw people in class drawing, they put the sharp point at a town, which is not correct. There should be no, like, this is totally wrong what I just did here. There should be no towns or dots inside the circle. Okay, so like I said, the center of the circle needs to be at the vertex, and the vertex is where the boundary lines intersect. Okay, very important. Okay, next one. So you've got these coordinates, so we need to figure out, they wanted you to find the midpoint. So in order to find the midpoint, I took the average of the x values, and we take the average of the y values, and then we end up with 3, 1.5. In the Desmos activity, when you type your answer with parentheses, you end up getting an error and it says that you didn't get it correct. And you actually did get it correct, you just don't put the parentheses when you're typing it in Desmos. For some reason it doesn't like that when it's doing error checking. Okay, next. Okay, so I'm going to zoom in so you can see a little better. And remember to hit pause if you want to re-watch a question, or to pause. So they've told you the midpoint between A and B is 3, 8, and the slope is -2. So the slope of this yellow line is -2. So to find the perpendicular slope, I'm going to take the reciprocal and change the sign. So since this is -2, the slope of the pink line is going to be +1/2. Okay, so our point slope form, this is point slope form. That's always the easiest way to start off with an equation. We know our slope is 1/2. We know our point is 3, 8, so I'm going to put in the 8 in for y, the 3 in for x. I do distributive property with the 1/2. I add 8 on both sides of the equation, and then I get this answer. You might want to hit pause and copy this down. Next one. Okay, so they've given me 2 points, 8, 5 and 11, 14. So the first thing I need to do, well, I have to do 2 things. I need to figure out the midpoint, and I need to figure out the slope. So to figure out the midpoint, I take the averages of the x values, so 8 and 11, and the averages of the y values, 5 and 14, and then we get our midpoint is 9.5, 9.5. Okay, and then we need to figure out our slope. So to figure out slope, it's the change of y over the change of x. So 14 minus 5 in the numerator divided by 11 minus 8 in the denominator. So the difference of the y values divided by the difference of the x values. 14 minus 5 gives me 9, 11 minus 8 gives me 3, so the slope of the yellow line is 3. So the perpendicular slope can have the opposite sign and the reciprocal. So the perpendicular slope is -1/3. All right, so now I put in -1/3 in for my slope in our point slope form equation, and our midpoint I'm going to put the 9.5 in for x, 9.5 in for y. Do distributive property with the -1/3, and then I add 9.5 on both sides. Make sure you copy this down very carefully and check your work. Okay, last question on this page. Okay, so use the Voronoi diagram, find the equation of the line that forms the edge between sites E and sites F. So what I'm going to do is I need to figure out where the midpoint is, just like we did on the previous one. So I take the average of the x values, 8 and 12, divided by 2. The y values, 28 and 18, add those together, divide by 2. So my midpoint is 10, 23. So I go over to 10, up, and the y value is 23, so my midpoint is about right there. Okay. So now I need to figure out the slope. So the difference of the y values, 18 minus 28, divided by 12 minus 8, and I end up with -10 over 4, and then which simplifies to -5 over 2. So my perpendicular slope, I'm going to change the sign so it's positive, and it's going to be 2 over 5. So now I put in my new slope, which is 2 over 5. That's the perpendicular slope. That's the slope for the pink line. and I'm going to put in my coordinates, which is 10 and 23. I put the 10 in place of x, 23 in place of y. Okay, I can do distributive property with the 2/5 to the x and 2/5 to the negative 10. And then finally we add 23 on both sides and we get this. You may want to hit pause to look at this some more. Okay, find the coordinates of the center and radius of the largest empty circle. So the first thing I did is I said, okay, here's a vertex, put the sharp point there, and then put the pencil at B. Okay, and then I drew my circle. And then I put the sharp point at this vertex, and then I adjusted the pencil to D. And then I drew my circle. And clearly, just from looking at this, you could tell the pink circle is larger than the yellow circle. But another thing you could do is you can say, okay, let's look. From here to here, I know that it's going to go over, from the center it's going to go over 1, 2, 3, and something. Now from here to D, fortunately, it's on the same line, isn't it? It's all in the same y value, so it can go over 1, 2, 3, 4, 5. I didn't even need to use the distance formula. So I know that the radius is going to be 5 units, and the center at this point is 10, 3. Now you will be using distance formula in other problems. So how do we do distance formula? It's the difference of the x values squared plus the difference of the y values squared. And this formula is in your formula packet. All right, next question. Find the center and radius of the largest empty circle below. So from this vertex, I put the sharp point, and then I put the pencil at dot B, and then I draw my circle, and then you can see that it goes through E, and it goes through A. I can put the sharp point at this vertex, and then have it go through C, and it goes through A and B. And I put the sharp point at this vertex, and it goes through D and B and C. And you can see from this picture, the pink circle is bigger, and if I count from here over to B, it goes over 1, 2, 3, 4, 5. So once again, the radius is 5, and my center is -3, 6. Hit pause if you need more time to look at this. Okay, page 3. So they wanted you, the first part is to find site Q. And so what I noticed is, okay, so we've got this boundary line right here. So we know that this part over here is not labeled, so but P is 1 unit away from the orange line. So I know that Q is going to have to be 1 unit away from the orange line also. And if I turn the paper this way, I could extend this line right here, and then you should be able to see that, look, from S to the boundary line is the same as from Q to the boundary line. Now if I turn the paper this way, if I extended this line here, then you could see from this line, let's just pretend my pen is that line, you can see that from R to the pen and from Q to the pen, it's this equal distance there. Okay, so I've put my dot there, and the coordinates of Q is 4, 1. Okay, and the next question was fairly simple. Find the area of this triangle with site P in it. And so one area of a triangle is 1/2 base times height. The base is 4, the height is 3. My area is 6. And then lastly, it says calculate the radius, calculate the distance from 9.2 to the nearest point. And so what we're going to do is, so 9.2 is right here. And if you look here, you can automatically tell, look, it's in cell R, so it's not going to be closer to Q. So I don't need to figure out this distance. I just need to figure out the distance to R. So R has coordinates of 5, 4, and here we've got 9, 2. So using my distance formula, the difference between the x values is 9 minus 5, and the difference between the y values is 2 minus 4. Now, 9 minus 5 is going to give me 4, and I square that and I get 16. 2 minus 4 is going to give me negative 2, and when I square a negative, we always get positive. Add these together, take the square root. The distance between the point 9, 2 and R is going to be this. Okay. Then the next slide, they asked you to draw the new boundary edges. So I'm going to do that for you right here. So they gave you, there's a new cell and a new site that we're going to add, which is 5, 5. So 5, 5 is right there, right? And we're going to label that D. Okay. And so sketch the new boundary lines and shade the cells with different colors. Okay. And so I need to figure out the. I'm going to have some line kind of between D and C, and some line that's going to be between D and B, and some line that's going to be between D and A. Right now I'm just going to draw a sketch. You don't really need to draw this right now because I'm going to show you my answer key in just a minute. So very lightly I'm drawing a dotted line, and so let's just say that looks like it's the middle, and so I'm going to draw a perpendicular line to the dotted line there. Okay. Now, over here, between here and here, dotted line, very faint. Halfway between here and here is my midpoint, and if I draw a perpendicular line, it's going to look something like this. I'm just drawing a sketch so you can see what happens. I'm going to show you exactly how to make your line perfect in just a minute. Okay, and then if I look here, halfway between A and D, looks like it's around there. Okay, and then so if I have my dotted line here, I'm going to draw my edge right there. Now let's see how well I did. Let's look at my answer key. Pretty close, right? Here was my sketch. It's not perfect, but here is what I drew, and let's talk about how did I get these values here. So what did we do? We found the midpoint between B and D, we found the midpoint between D and C, and we also found the midpoint between D and A. So I needed to figure out these midpoints. And then the other thing I needed to figure out was the slope. So I've got my work right here that I can show you. So to figure out, so let's talk about one of these examples, and then you should be able to see the rest for yourself. So between B and D, so to figure out the slope, we could change of y over change of x. So 5 minus 10 in the numerator divided by 5 minus 4 in the denominator. And so we get the slope of between B and D, the slope is going to be negative 5. So the perpendicular slope is going to be positive 1/5. So sign changes and it's the reciprocal. Okay, and then I take the averages of the 2 points. So 4 plus 5 divided by 2 is going to give me 4.5, and 10 plus 5 divided by 2 is going to give me 7.5. So I planted this point right here at 4.5, and I went up 7.5, and that's my midpoint. Okay, and then so using that midpoint, then I had a slope of 1/5. So I went over 1, 2, 3, 4, 5, and then up 1. And then once I had that, I drew my line with a ruler. And notice how we squiggled this part out, because here's when we hit the original boundary line, and this pink line doesn't go further into here because now we got cell A. So this blue line gets squiggled out, and this part here gets squiggled out, because the cell A goes between this navy blue line and the orange and the navy blue line. This is all in cell A, and this squiggled out part shouldn't be there. But it was important for you to see how to get there. Okay, and so here's my work. You may want to hit pause. Okay, and the original lines here, notice those are squiggled out as well. Okay, last page, I think. Yes, last page. Okay, very important question. Can a site also be a vertex? The answer is no. The vertex is the farthest location between sites, therefore the vertex it's truly the opposite of a site. The vertex is the farthest place away from a site. Okay, so find the center of the largest empty circle, and there is more than one solution. So I used my compass and I put it at the various different vertices. They tried to confuse you here because they actually labeled some of these vertices with an alphabetical letter. The way I knew that this V here was a vertex and not a site is because the boundary lines connected here. So that's how I was able to tell that this point right here is a vertex and it's not a site. So the sites here are D, F, E, G, C, and B. Those are the sites. And this here is not 221, it looks like it's 22. Okay. So anyways, it looks like these two orange and blue circles have the biggest radius. So their centers are 15, 15 and 16, 14. And then to figure out this radius, I went from one of the points down to a point on the one of the points at the edge of the circle. So here are 15, 15 to 11, 8. I use the difference of the x values squared plus the difference of the y values squared. So 15 minus 11 gives me 4. 15 minus 8 gives me 7. Square those values. 16 plus 49 gives me 65. And square root of 65 gets me 8.606. I hope that helps. And there we go.